Welcome back for the third session. Here are the Daria. We are here with Daria. Thank you, Daria, for joining us. Would you like to introduce yourself?
Yes, I can.
Yeah.
Hello, I am Daria. I am lead computer vision engineer from Accenture Baltics, and today I am present to talk about practical aspects of applied modern computer vision technologies and show you some examples which project for computer vision we have and which techniques we are using.
Okay, that's great. So I remember the session is 40-45 minutes. If you have any question, you can put on the time session. I will provide to Daria at the end of the presentation. So Daria, the stage is yours. Good luck.
Okay, thank you. Um, Hello, everyone. Again, my name is Daria, and actually I am blind. I'm blind just because I cannot see which machine can, but I'm the person who can train some machines how to see. And today I'm just talking about how to train some machine to see. A little introduction about me. I already mentioned that I am working in Accenture Baltics. I have been working here around 5 years and 8 months. Currently, I'm a computer vision engineer, but before it, I also had some project with reinforcement learning and other AI techniques, such chatbots, NLP, and so on. Um, Recently, I got my cloud architect associate certificate for AWS, but unfortunately, in my current project, I am using Azure, not AWS. And before I changed my career to AI expert, to computer vision engineer, I was a test manager for 9 years. And from this time, I was certificated like test manager from ISTQB. And of course, I'm just a human. I have a family, lovely husband and son, and very active son. Um, just a little bit personal about me. But now I'm telling you about my company a little bit. Actually, Accenture Baltics, it's the largest technology center in Europe. We have more than 2,000 people already and two locations, Latvia and Lithuania. In Latvia, it's Riga and Vilnius. And we are hiring a lot. And if you are interested to build a career in Accenture Baltics, please check this QR code. It's in the right top corner. Please check our open position and you could apply. And also we provide some boot camps for interns just to train someone who just want to enter it to IT from other areas and something like that. A little bit about my capability. My area, it's consists around 80 people, but we have more than 8 years of experience and more than 250 already delivered projects to different clients. And it's not only about computer vision, it's also about data science, chatbots, and something like that. And almost 90%, it's the largest trend in all Accenture Baltics. Almost 90% of our people already certified in the cloud. It's different cloud in AWS, in Azure, or Google Cloud Platform. Basically, what capabilities we have under data and AI, it's intelligent automation, of course, RPA, OCR, BPM, and process mining. For conversational AI. Actually, we developed our own platform, which currently using for global Accenture for for all the world. It's a special platform which let you to create your chatbots from scratch. And also we have separate industrial and cloud platform. And of course, regarding data, my favorite, my guild, machine and learning data science, when we have computer vision, reinforcement learning, NLP, predictive analytics, advanced analytics, and a lot of more data science capabilities. Separate data engineering and data architecture guild. And of course, augmented insight. Sometimes we even have project in metaverse. And also Accenture Baltics has its own Riga Liquid Studio and Vilnius Grow Studio just to create some innovation projects which connected with computer vision, metaverse, and quantum computing. Okay, now just let's talk about our computer vision projects. I think all of you has some situation when you just bought something, brought to brought it home, and only after that realize that, oh gosh, it's damaged. Some curly young guy in the plant just made a mistake and passed the damage. You were disappointed, right? You waste money. But that's why actually we uh, proud to propose our solutions. It's a quality inspector. Basically, we implement this quality inspector for one big client, a global car producer, and it's a project actually we developed from scratch, from camera installation, from hardware installation, from camera configuration, also make all data fusion, data labeling, model architecture from scratch, model architecture creation from scratch, model selection, just select some techniques and provide some innovation, our own architecture, of course, integration testing and deployment and support, actually maintenance, all use cases with now in life. Now we have more than 200 use cases in life, and actually not a nine plants over the world. And we're really proud that all our solutions in life already save from 10,000 till 1 million euro per year for our client. But of course, we faced a lot of struggle requirements from our client, and one of them, it was minimum accuracy for every use case, 99.5%. 99.5%. For some critical use cases, actually, it was 100%. That almost impossible to achieve for computer vision. And maximum time for model performer, only 20 seconds per car. Do you know why? Actually, client just creates such requirements just because conveyor is always moving. Because if you just have to stop conveyor, it will cost our clients 3,000 euro per minute. 3,000 euro per minute. It's a lot. And that's why conveyor is always moving. And you can just imagine that some big and shabby plant worker with oily hands trying to install airbag in one of the car. Actually, it's end of the working day. He is tired a little bit, and he didn't notice that he made installation wrong because airbag airbag was turning around, but he didn't notice and no one noticed. Only 10 seconds left just to notice this mistake, and no one noticed. But conveyor is always moving. But you can imagine on the monitor, it's a text, and okay, CV solution noticed this mistake. And actually, this car just moved to another conveyor and airbag has been installed. And you know what? One more life has been saved. But do you know actually what any use cases we can implement for this computer vision solution? I can show you actually only two examples because it's a client project. Let's talk about one of them. It's a plug tire wheel. You can see that for this use case, we should not only detect all plugs on a wheel, but also should calculate how much these plugs, 3 or 4. It should be 3 for some series and 4 for other series. And also, we should classify, is it plug inside or not? For this example, I think I cannot show. For this example, let me check that I can show. Yeah, I can show. For this example, this it's plug inside. For this, it's plug inside, but here is not plug inside. It's an OK. This use case has been developed for 3 months from scratch to go live. And actually, this solution works with 100 precision and more than 99% recall. But you can ask me actually which technologies we are used. Of course, simple object detection with RetinaNet and with backbone 101. But after that, when we cropped these all plugs, we also implemented our own solution, which called deep metric learning classification. It's classification model, and based on that, we can just make a conclusion: is it plug inside or not? A little bit later, I will share a link to our paper with this deep metric learning solution, and you can check it yourself. But also one more example. Let's move on. It's about airbag. Actually, this is how airbag looks like when it's installed. And here, actually, it's a tricky use case and very critical because it could save life to somebody in the future. We also should detect that airbag has been installed, and we also uh, should check that this airbag cannot wasn't turning in a wrong way. With human eyes, actually, I cannot notice it, but I can. And here we also use the same techniques, also object detection with RetinaNet and deep metric learning for classification, just to check is it turning around or not. But precision may be not so good for this one. Of course, 100 precision, but 97% recall. But for this use case, it means that actually workers should check only NOK results, not like all results. And this use case saved 50,000 euro per year for our client. Okay, let's move on. Actually, now let's move to another location. You are in a jungle and you can notice some young curly girl who actually can try to cover it from some animals and take a photo shot. She tried to come closer and closer to the elephant, but elephant noticed her and ran away. Damn it. Actually, she spent 3 months just to try to catch and make a photo shot for elephant, but she's just a human, remember? That's why we just provided another solution with the camera traps. Of course, it's not maybe new solution, and a lot of companies also tried this one. But it's our also client project for some client from Guyana. And for this one, all cameras located here in this uh, camera traps, and actually it just take a shot when someone is moving. That's why you can imagine this, right? A lot of some problems with some leaves which can cover it, the animal, or some different movements, some shadow movement or something like that, or some insect movement. Actually, the data sets which was created was very consistent. But anyway, all AI solutions also should be kept. All calculation actually also should be performed inside of such traps, which means that we can try only TensorFlow Lite and very light models for these solutions. And we used uh, client and public dataset. Public dataset you can check here, and also some client dataset, but it was very, very imbalanced. I can show you some examples actually how it looks like. Let's see. Okay, this looks okay. We can detect, yeah, it's elephant, it's a bird, it's leopard, and it's kind of pangolin, I would say. But what if you have picture like this, or like this, or like this? Yeah, we can detect something, but who is it? And we faced a lot of challenges with such projects. What we did actually, first, we just make some um, combinations for similar classes. For example, we combine Epi and chimpanzee for one class as a monkey, or some rats and some other different mouses also under one class. And after that, we also create class like a human or blank pictures, just to be sure that model can detect that no one appeared on these pictures, and also implement a lot of traditional data augmentation. It's a random resize crops, histograms, horizontal flip, and so on. A lot of place with colors. But also we should exclude a lot of images if it looks very, very similar. For example, camera just made a lot of shots, like 50 shots in per minute, and they looks completely the same. And this one, but it's still very imbalanced, you see. class actually, okay, we lost the presentation, right? No, it's return. Okay, this is a class which is the most popular. It's a Red. You can see how it looks like. It's one of the middle class Hogred River. And Pangolin class of Pangolin actually consists only from 21 images. Against 21,000, it looks like, okay, Pangolin might be detected. And now I would share some results with you. Actually, this is our confusion matrix, whereas you can see ground class, ground truth, and prediction. And basically, you can see that, of course, elephant has the best results. Also, blank pictures has a good results without any animals inside. Bird has a good results. And basically, in general, we have 89 accuracy. But for some separate classes, we have 90% accuracy. It's very good result. And we delivered such project in 3 months by one computer vision engineer. Currently is working in Guyana, and they are going to deploy it to another regions. Also, I wanted to show you how normalized data set looks like. Just let's see how it looks like. Of course, here, actually human eyes cannot notice something, but after histograms and some playing with exposure, you can see that, yeah, our small animals is here. Of course, it's not professional photo set, but you can just detect who is it. And let's see actually how our misclassified pictures looks like. Here. I think even with human eyes, it's really hard to see something. Do you tell me who is it? Or who is hiding here or here? It means that actually our model maybe doesn't work perfectly, but it's doing much better than human eyes. And also regarding these projects, I really proud you to share results actually which from not our data set, but from our colleagues from epsilon.com. But we also checked our models on their data set, and it's our model results. Can you notice where is the bird, right? It's here. With human eyes, it's impossible to notice. I didn't notice it personally. Actually, this bird looks like here, but the solution of our colleagues and our solution detect, yeah, that it's located here, and also detect that it's on cooling group rail, not like a Okay, what we should do next with this project and what's lesson learned? Yeah, a lot of things might be tested, and maybe we should create more balanced data set because dirty data doesn't guarantee a good result, remember? And also for some project, a device maybe it's not so sufficient, and we should have like more resources just to run real large models. For example, if you have two models, detection and classifications, it's impossible to perform on such small result, some such small device. But even for such imbalanced data set, it's still possible to get 90% accuracy for particular class. Okay, a little bit more about our other project. Now just think about your old relatives, about your grandpa, grandma. I really hope that maybe not all of your old relatives just have to take some pills. And I really hope that all of them didn't make any mistake in their pills. Just because maybe we are trying to implement our solution how to prevent mistakes in the pills. Unfortunately, I know maybe not so good statistic, so sad statistic from USA that one person per day just hurt it or even died just because he or she just took wrong pills. And sometimes it's not their fault, but it was fault of pharmacy or some plant actually. And that's why we created our special solutions and even created our own hardware how to prevent if we have some wrong pills in a box. How it has been started? Basically, it has been started from hackathon. We are started on hackathon solutions, and for 2 days, our team from 5 people developed 3 solutions how we can prevent that we have some wrong wrong pill in the box. We tried 3 different solutions. And realized that actually our deep metric learning, our own product, was the best one. And here, if you can, if you wanted to try, please scan this QR code. It's a paper about our deep metric learning solutions, which actually has been created for this project, and after that, just scale for our other project. I just put it here a little bit. But we tried Autogun. All these solutions actually open source. You also can try it because it's also have a link here. And when I share my PDF, you can also try it, this one. Anogen and Padim, also patch core anomaly detection, and our own solutions. And here are the results. Actually, Anogan, yeah, it has very good solutions. But sometimes, and actually training was really good for 200 epoch. We see that, yeah, actually the loss function decreased a lot, but it's still not so close to 0, right? It still has a lot of mistake here. For Padim, it also works, but it's not so robust to some things which can cover it any pills. If all types of pills you can see clear, yeah, it works. But if not, it couldn't detect anomaly very clear. But for deep metric learning prediction, actually, it's completely working. And the accuracy also was 80% after even 50 epoch. And here you can see how actually model redefining its knowledge space, yeah, just to distinguish anomaly points, like not anomaly and anomaly. And here you can see more example. Unfortunately, deep metric learning is not detection model, and we don't have bounding boxes here, but you can see that it can classify, is it located anomaly inside or not? And here you can see its accuracy for every particular image. It's quite hard. Even for this one, when we have a rectangle and round, and actually sometimes it's look very close, but it still have some 0.97 anomalies. After that, actually, we sold this project to our client in USA and implement this solution on the client side. And for this project, we also implement some kind of self-supervised learning solution. Just because if you have a new pill, you can just create a new class, additional new class with part of image. Just push a retrain button and it will retrain itself without any config changes, without any some changes of future detection and something like that of future extraction, just to add a new class and that's it. And now for this client project, we shouldn't even make any support or maintenance for our client. They just retrain our models themselves. And one more project, which I can show you, last but not least, it's about damage building detection. Okay, I think all of you have insurance, right? For your car, for your house, maybe for your flat. And I think a lot of you already face that sometimes insurance didn't pay for you, or sometimes insurance didn't estimate actually the damage or what you got during some incident, right? This project will help insurance company or some general people just to evaluate actually the damage of building detection. This is proof of concept, not a client project, and we just used public dataset for it from Kaggle. But for client project, we also can use some pictures from drones. But sometimes for some particular region, it could be also used for GPS pictures. And what is the problem? For example, we can notice some damages which appeared on buildings after disaster, like post-disaster. And also we have pictures before, like pre-disaster, for every particular buildings, and we can compare them with each other, and after that just can make a conclusion how much is it damaged, and for different building just detect and predict how much the damage it will be or it could be for some disaster. For this, we also used two different models, 18 backbones and efficient utter boxes. But we detect buildings from pre-disaster and post-disaster images. And after that, we compare the detection and match them to each other and send it to damage assessment models. For damage assessment models, we actually create a representative vector and compare them. If representative vectors for pre-disaster buildings and post-disaster buildings has a similar direction, it means that building doesn't have any damage. If not, it has a damage. Let me show you how it looks like. Here we detect a building, cropped every building here, and after that just create a representative vector, and you see if it has the same direction, yeah, it's no damage. But if it's particular different direction, it means that maybe damage, maybe building has been destroyed. Some examples. Actually, it's pictures not from drone, from GPS, and it's more like a town and some countryside in the forest. You can see that it can detect any buildings, even such as small buildings. And how damage assessment training looks like. In the beginning, we have completely mess, and we cannot detect where is damage or no damage building, but it's like epoch number 0. But we are using 100 epoch and 400 iterations for everyone, and you can see how it looks like. Yeah, at the end, we have a very big difference between damage and no damage. But unfortunately, it's like a round. I cannot stop it, sorry. Okay, actually, what we are going to do is this project. But we are trying to improve our results, and we have a plan also implement self-supervised learning, which I already talked before with the PILS project. And also we are trying to implement like some semantic segmentation just to show which part of buildings will be damaged or might be damaged. Visual transformers also can help us, in theory, indicate some damaged parts of the building or some improved. For example, if post-disaster we have almost destroyed building, and also some image reconstructions with autoencoders, just because it might help architects to evaluate how much they should invest to recover these projects, to recover these buildings. And also it might be helpful for insurance company just to calculate much more clear the price for insurance. And maybe sometimes it could help to detect, to prevent some disaster. For example, if you have some water problems or some wave problems or some storm can be expected. Okay, actually, it's all project which I have. And a little bit about conclusions. Well, I know that educated computer vision robots are real, and it's only we are responsible what they will learn. But that's why maybe on this stage we recommend to pay attention to the next technologies. It's a self-supervised learning, synthetic data generator, because I already talked a lot about some imbalanced datasets, visual transformer, and deep metric learning classification. I hope you download the paper. And so that's it from me. Thank you.
Thank you, Daria. I think I have too lot to study in the next day. Generally, I see a lot on natural language processing, so I'm very interested on computer vision. You did us an incredible overview of projects. So thank you, thank you very much. But see you. Bye. Bye. Bye.